E aí, pessoal, sejam bem-vindos para mais uma live estudando Java até a vaga de estágio. Eu tô gripado, tô com dor de garganta. Tô quase sem voz aqui, então não vou falar muito. Por enquanto, enquanto eu vou comendo aqui, eu vou ver esse vídeo aqui de estrutura de dados e algoritmos. Ai, caramba. E é isso. Enquanto eu fico mutado aqui. Valeu.
Hey, what's going on everybody? It's your bro, hope you're doing well. In this video I'm going to explain the stack data structure, so sit back, relax, and enjoy the show. Alright everybody, stacks. A stack is a LIFO data structure. LIFO is an acronym for last in, first out. This allows us to store objects into a sort of vertical tower, like a stack of books or a stack of CDs. We use the push method to add objects to the top of the stack, and the pop method to remove objects from the top. So here's a real-life example of us creating a stack data structure. After declaring our stack, we can add objects to our stack. The objects that we'll be adding are various video games. To add an object to our stack, we use the push method, like we're pushing something onto our stack. So let's push Minecraft onto the bottom of our stack. And then next, we'll add Skyrim, then maybe some Doom, then Borderlands, and then Final Fantasy VII. So this is a LIFO data structure, last in, first out. To access objects on the bottom of our stack, we first need to pop or remove objects from the top of our stack. If I need to access Minecraft on the bottom, I don't want to pull this from the bottom because everything on the top is going to fall, right? So that's kind of the concept. So in order to access Minecraft on the bottom, I need to pop or remove objects from the top in order to access objects on the bottom. So in order to access Minecraft, I need to remove all the games on the top of my stack. So that's kind of the point of a stack data structure. Now let's create a stack. The language you use really doesn't matter for the most part. You can implement a stack in Java, Python, C++, C#. The language really doesn't matter. However, the syntax might be slightly different. I just so happen to be using Java, so I'll stick with that. Now to push objects onto our stack, we first need to declare our stack and instantiate it. So let's do that. Stack. Then we will list the data type of the objects that we will be adding to our stack. Luckily, strings are a type of object, and they're fairly simple, so we will create a stack that can store strings, the names of video games. And I will name the stack stack to keep it simple. Stack equals new stack. And I will list the data type and then add a constructor. Okay, so we now have a stack data structure. Now with stacks, they have 5 unique methods. Let's take a look. Now with stacks, we can push an item onto the top of our stack. We can pop an item from the top of the stack. We can peek at the item at the top of the stack. We can check to see if our stack is empty. And we can search our stack for an item. So those are 5 unique methods available to stacks. Let's first check to see if our stack is empty. So let's use system.out.println stack.empty method. And currently our stack is empty. That is true, but that'll change soon. So let's push some games onto the top of our stack. So we type the name of our stack, and use the push method, then pass in our object. So we will pass in a string, the name of a video game. Let's add Minecraft first. Then let's add Skyrim. Then Doom. You can pick your own games if you want, I don't care. Then Borderlands. And then Final Fantasy VII. FFVII. Okay, let's check to see if our stack is empty now. So let's move this line of code to the bottom. And run it. So our stack is no longer empty. This returns false. So with the stack, we can at least take a look at the items within the stack without removing them. So let's use system.out.println and I will print my stack. So this will print all of the objects within my stack, beginning with Minecraft, then Skyrim, Doom, Borderlands, and Final Fantasy VII. However, by printing our stack, we're not removing items from the stack, so that's completely fine. So this time, let's pop the topmost item from our stack by using the pop method, stack.pop. And we don't need to list an object because pop will always remove the topmost object from our stack. So now Final Fantasy will be missing from the top of our stack. So if I was to repeat this again, well then this will remove Borderlands, and then Doom, then Skyrim, and then lastly, Minecraft. Then if you pop again, this is what happens. An exception. Empty stack exception, so that's something to keep in mind. Now, when you pop the topmost object from a stack, this will actually return that object. If you need the object from the top of the stack, you can pop it and then assign it to something. So let's say string my fave game equals stack.pop, and then I will print my fave game, and this will print Final Fantasy VII, and it should be missing from the top of my stack if I was to print my stack. So Final Fantasy VII is no longer in my stack because I popped it, then assigned it to the string variable of my favorite game. So in order to take the topmost object from a stack, you use pop and then assign it to something. If you ever need to take a look at what the topmost object is within your stack, you do not want to use pop because that will remove it. You can instead use the peek method of stacks. So what I'll do is system.out.println stack.peek, and then immediately follow this with printing my stack. So let's run this. So the topmost item within my stack after using the peek method is Final Fantasy VII. Then after printing my stack, Final Fantasy VII is still at the top of my stack. So if you ever need to take a look at the object that is at the top of the stack without removing it, you can simply use the peek method. If you need to search for an object within the stack, you can use the search method. Let's print stack.search, and we pass in our object as an argument. So the very first item in a stack will have a position of 1. You would think it's 0, but it's actually 1. Now let's find Borderlands. That will be in position 2 from the top. Then Doom would be, of course, 3. Skyrim is 4. Then Minecraft is 5. So if you search for an item that is not within the stack, like Fallout 76, well then this will return -1. If search does not find this object within your stack, it will return -1. So with stacks, we can actually run out of memory. So let's add like 1 billion copies of Fallout 76. We find Bethesda's warehouse of unsold Fallout 76 games. So we'll create a stack of 1 billion copies of Fallout 76. We can do this using a for loop. Int I equals 0, as long as I is less than like 1 billion. That's probably close enough. Increment I, then we will push a copy of Fallout 76 to our stack. So stack.push Fallout 76. And this is what happens.
A few moments later.
So we will run into an out-of-memory error due to the Java heap space. So it is possible to run out of memory when adding objects to our stack. Now, this is an interesting feature that may or may not happen to you if you add 1 billion copies of Skyrim onto a stack. Damn it, Todd Howard, you did it again! Now, what are some uses of stacks? Here's a few examples. One, we can use them in undo, redo features in text editors, like when we go to edit, then undo typing, or redo typing. We can move back or forward through browser history by hitting the back or forward button in the top left corner of most web browsers. We can implement them in backtracking algorithms if we need to navigate a maze or search through file directories. And another is that we use them when calling functions. Whenever we call a function, we add what is known as a frame to the call stack, but I'll probably save this topic for another video. So in conclusion, everybody, a stack is a LIFO data structure. Last in, first out. It stores objects into a sort of vertical tower, a stack of objects. You use the push method to add objects to the top, and the pop method to remove objects from the top. So those are stack data structures. In the next video, we'll be covering queues, which work a little bit different. So if you can, give this video a thumbs up and drop a random comment down below. But yeah, that is a stack data structure in, well, computer science. What's going on, everybody? It's your bro. Hope you're doing well. In this video, I'm going to explain queues in computer science. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Whoa, hey, we're talking about queues today. So queues are a FIFO data structure, not to be confused with FIFA. FIFO as in first in, first out. An example would be a line of people. It's first come, first serve. Whoever's there first gets helped first. So this is a collection designed for holding elements prior to processing. It's a linear data structure. Here's an example. Imagine that we're a cashier and we're selling tickets to a concert. We will help whoever approaches our register first. It's first come, first serve. In other words, it's FIFO. First in, first out. Unfortunately, a wild Karen appears and she would like to talk to the manager. Now, Karen is going to waste everybody's time, so it's going to be a while. In the meantime, Chad enters the line. He will enter in at the back and wait his turn, followed by Steve and then Harold. So Karen is at the head of our queue, our line, and Harold is all the way at the back, our tail. As you can see, Harold is very anxious right now. Once Karen has been defeated, Chad will move to the head of our queue. So Chad will now be helped next, and Harold will still be at the tail until somebody else enters the line. Once Chad has been helped, he will move out of our queue, and Steve is at the head now, and the tail will move as well. And then once Steve has been helped, Harold is the only one currently waiting in line for his tickets. He will be at both the head and the tail of our queue. So that's kind of how a queue works. It's first come, first serve, FIFO, first in, first out. If you were here first, then you will be helped first. Now, the concepts of adding and removing objects from a queue are known as both enqueuing and dequeuing. Enqueuing is the concept of adding an object to the end of our queue, our tail, and dequeuing is when we remove an object from the head of our queue. Now, what methods do you need to enqueue and dequeue from a queue? Well, it really depends on the programming language that you're working with. A lot of you voted for data structures and algorithms using Java, so I'll probably stick with Java then. Here's an example. Now, to enqueue and dequeue, we need, well, a queue. So let's create one. Queue. Then we need to list the data type of the objects that we're going to add to this queue. Let's work with strings because strings are objects and they're fairly simple. And I will name this queue Q equals new. Now check this out. I will attempt to create a queue object and instantiate it. And the data type is string and I will add a constructor. Now we cannot instantiate the type Q. Here's the reason why. So if we take a look at the Q class right here, Q is actually an interface and not a class. And based on our lesson on interfaces, we cannot create an instance of an interface. An interface is meant to be more of like a template that we can apply to another class. So to utilize Q technology, we need a class that implements Q. Now, taking a look at our Java collections hierarchy, there are two classes that implement queues, one of which is the linked list, and the other is the priority queue. Now, priority queues, they will rearrange their elements based on a certain priority, so they wouldn't be a good example. So to utilize the features of a queue, we are going to create a linked list because we cannot instantiate a queue itself because it's an interface. With that being said, let's change equals new queue to equals new linked list. We won't be equals new a queue itself because
Agora é o que o Fiasco falou no curso lá. Que quando for instanciar uma queue, tem que colocar link de list ou priority queue que tá ali no canto. Porque elas são classes, né? Tipo, esses aqui todos são classes. Aqui é abstract class e aqui interface, né? Então, aí eu tenho que colocar vertical link de list para implementar na interface. Tipo isso, tá vendo?
because it's an interface. With that being said, let's change equals new queue to equals new linked list. We won't be focusing on any of the features of linked lists. We'll save that for another video, maybe the next one. I haven't decided yet. So we will only cover the features that linked lists will utilize via the queue interface. Now, with the queue interface, there are 3 methods that we inherit from the collection's parent class: add, remove, and element. These will do approximately the same thing as enqueuing, dequeuing, and peeking at the topmost element. However, they throw exceptions, and according to the documentation, it's actually better to use this column of methods instead. These will return a special value. We have offer, which will enqueue or add an element to the tail of our queue. Poll will dequeue. It will remove the head of our current queue. And then there is also peek. It will not remove the head, but it will examine it and return it. So those are the 3 dedicated methods that we implement via the queue interface. There are some additional methods too, which we'll cover later, which we inherit from the collections class. So let's begin by offering a bunch of people to our queue. This is how we enqueue or add elements to our queue. So first in our line, we have Karen. So to add her to the queue, we would type the name of our queue, queue.offer. And we will offer Karen to the front of our queue, and she would like to complain to the manager. Next, we have Chad, queue.offer Chad. Then we have Steve. And lastly, Harold. Okay, now if we were to display our queue, we'll place it within a print line statement. We will pass in queue as an argument, and this should display our queue in order. First, we have Karen at the head, then Chad, Steve, then Harold at the tail. One method that we implement from the queue interface is the peek method. We can use the peek method to examine and take a look at the object at the head of our queue. We're not actually going to remove the object at the head of the queue, but take a look at it. So within a print line statement, I will use queue.peek method. And after peeking over our cash register, unfortunately, Karen is at the front of the line. Now to dequeue, we can use the poll method. So type queue.poll, and this will dequeue your queue. So Karen is no longer at the head of our queue. So let's poll a couple more times for practice. So after polling twice, Karen and Chad are now gone. Using poll a third time, we'll remove Steve, and lastly, Harold. Now, the nice thing about the poll method is that it will not cause an exception. According to the Java documentation, you can use element to peek, but it will throw an exception. So if I was to use element at the end, this would cause an exception then. So usually it's preferable to use this column of methods, even though they're similar. These will not throw exceptions: offer, poll, and peek. Now with queues, there are some additional methods that you might be interested in. The queue class will extend the collection class, so the queue class inherits everything that the collection class has. And there's some pretty useful methods within here. I'll show you a few. So the first is that we can check to see if our queue is empty. So within a print line statement, I will type queue.isEmpty. And if our queue is empty, this will return true. So if I move this line of code after we offer a bunch of strings, a bunch of people to our queue, if we check to see if our queue is empty, that will be false. There are people currently within our line. So that is the isEmpty method. We can also check to see the size of our queue. How long is our line? System.out.println queue.size. And the size of our line, our queue, is 4 objects. We have 4 people waiting in line to be helped. So that is the size method. And another is the contains method. We can check to see if our queue has a certain object that we're looking for. So within a print line statement, I will type queue.contains and then pass in an object. Let's check to see if Harold is at the back of the line. He's been waiting here patiently. Queue.contains Harold. And according to the contains method, Harold is in fact within our line. That is true. However, this method does not give the index, the position in which Harold is in. Imagine that we yell out, "Hey, Harold, are you there?" And he yells back, "Yeah," or "True." That's kind of how the contains method works. So these are three useful methods that queues inherit from the collection class. Now, where could queues be useful? They're actually used in quite a number of things, but here's a few examples that came to mind. So one, they can be used in keyboard buffers. Have you ever typed so fast that the computer couldn't render all of the characters onto the screen? And all of those characters were added to a buffer. They were all displayed in sequence, and they were waiting for their turn to be displayed. So with a keyboard buffer, letters should appear on the screen in the order that they're pressed, right? First in, first out. They're also used in printer queues. Print jobs should be completed in order, so we would start with page 1, then page 2, and just follow that pattern. And as we discussed before, they're used in linked lists, priority queues, as well as breadth first search algorithms. Well, everybody, in conclusion, a queue is a FIFO data structure. First in, first out. It's a collection designed for holding elements prior to some sort of processing. It's a linear data structure. Imagine a bunch of people waiting in line. To enqueue, that means to add an element to the tail of our queue to the end. We can use the offer method in Java. To dequeue, we would use the pull method in Java. That will remove the element at the head of our queue. So that is the queue data structure. In the comments down below, let me know what you would tell Karen if she asked to speak with your manager. And that, ladies and gentlemen, is the queue data structure in the field of computer science. Hey everybody, it's your bro, hope you're doing well, and in this video we're going to discuss priority queues in computer science. So sit back, relax, and enjoy the show. Hey, what's going on everybody? So priority queues. A priority queue is a FIFO data structure, first in, first out. However, a major difference with priority queues is that before we start polling and serving elements, we put them in some sort of order. Higher priority elements are served first, before elements with lower priority.
In this video, let's try to work with sorting. So let's
Fala pessoal, tudo bem com vocês? Trazendo mais um vídeo. O vídeo de hoje é sobre ordenação de lista. Eu vou mostrar as duas formas da gente fazer isso, usando o comparable e o comparator, tá? Vou mostrar a diferença dos dois e como é que a gente usa eles para ordenar a nossa lista, beleza? Então bora para o nosso vídeo. Bom galera, já deixei pronto aqui uma lista de string, tá? Como é que é essa lista de string? Ela tem camiseta, meia, luva e agasalho, são 4 itens aqui, né? Como se fosse uma lista de roupas aqui. E tô mandando ele exibir essa informação aqui, tá? Vou rodar isso aqui pra gente poder ver o que acontece. Ele mostra aí camiseta, meia, luva e agasalho da forma que foi passado aqui, tá? E se eu quiser ordenar esses caras pela ordem alfabética, tá? Pela ordem lexicográfica. Bom, eu venho aqui, uso a classe collections.sort e ele recebe uma lista, tá? Como vocês podem ver. Vou passar aqui a lista. Beleza? Ele vai ordenar E depois eu vou mandar exibir de novo minha lista, tá? Então eu vou rodar isso aqui e ele vai ordenar alfabeticamente aí pra gente, tá? Então começa com agasalho, depois camiseta, depois luva, depois meia. Beleza? Importante, se vocês estiverem aqui devolvendo uma lista, tomar cuidado para não devolver uma lista imutável, beleza? Como se, por exemplo, estivessem usando o list off aqui. Não daria certo, porque a ordenação vai mexer dentro da lista, tá? Então, um list off, por exemplo, que devolve uma lista imutável, não daria certo aqui, beleza? Então, usei um array as list. Bom, aqui a gente está ordenando nossa lista. E se a gente estivesse ordenando, por exemplo, uma lista de produto aqui, beleza? Get products aqui.
Agora eu vou ter que iniciar aqui para abrir o IntelliJ. Então eu nem vou mexer no código hoje. Continuar vendo aqui o vídeo de estrutura de dados.
Tá? Esse foi um outro método que eu criei, beleza? Ele cria uma lista de produto e devolve essa lista, tá? Minha classe produto tem duas propriedades, o nome e o preço. Aqui, como vocês podem ver, camiseta, meia, luvas e agasalho, tá? Bem simples. Deixa eu até mover isso aqui para cima para vocês poderem ver melhor. Bom, ele vai devolver na ordem que eu criei aqui, que é começando com meia, depois camiseta, depois luvas, depois agasalho, tá? Então vou mandar printar para vocês verem. Deixa eu apagar isso aqui. Vamos rodar isso aí. Então ele roda aí e devolve meia, camiseta, luva e depois agasalho ali, beleza? E se eu for ordenar, não dá certo, tá? Por quê? Se a gente passar por cima aqui da collections.sort que está dando problema, ele vai reclamar que o produto não está implementando comparable, tá? Então a gente vai resolver esse problema aqui. A gente vem aqui em implements, comparable e passa produto aqui, que é o tipo que a gente quer ordenar, tá? O comparable recebe um genérico, no caso a gente está usando produto. Ele vai mandar implementar o compare to, tá? Porque a gente está implementando uma interface, então a gente precisa implementar os métodos dessa interface, tá? E vocês vão ver que aqui ele para de dar erro, beleza? E por que com a string não ocorreu esse problema? Se a gente entrar dentro da classe string, vocês vão ver que ela já implementa o comparable, tá? Por isso que não ocorreu esse problema na hora de a gente usar o collections.sort, tá? Bom, como é que vai funcionar essa ordenação aqui? A gente tem dois carinhas para comparar, tá? O atual, tá? O this, tá? Que a gente está usando aqui, e o que ele está passando pelo parâmetro, tá? Então ele vai ordenar dois carinhas e fazendo a ordenação total de todos os elementos, sempre comparando dois, tá? E o que a gente vai devolver para ele? Ele está esperando um int aqui. Se o preço atual, tá? A gente vai ordenar por preço, tá? O menor preço vem para frente. Então aqui entre esses dois, o camiseta tem que estar na frente da meia, beleza? O preço atual for menor que o produto get price, tá? O preço que a gente está comparando aqui com o preço que está vindo pelo parâmetro for menor, a gente vai retornar um -1. O que isso quer dizer? Que se esse carinha aqui for menor, ele vai jogar ele mais para frente, porque eu estou retornando -1, tá? Então ele joga o -1 mais para frente. Mandou comparar meia e camiseta e eu retorno -1, o meia fica na frente, tá? Então, se o this.getPrice for maior que o produto getPrice, eu vou retornar 1. O que vai acontecer? Se ele comparar, por exemplo, aqui, que é o caso aqui que a gente está vendo, meia com camiseta, O meia é o this. O camiseta está vindo pelo parâmetro, tá? Como o meia tem um valor maior que o da camiseta, ele vai cair dentro desse if e ele vai retornar 1. Como ele retornou 1,
this comparator interface and the collection class sort method, things are pretty easy. So that's what we're going to talk in this particular video. And yes, if you created here called, okay, now let's try inside the java.lang package. So this one I'm going to, hey, sort it, and I'll just say temp been sorted to the list. And we know that in the array list, whatever we insert, the order is always going to be preserved, right? So right now our intention is to sort this particular list. So to sort it, I'll do collections. There is a class called collections in the java.util package. In that collection class, I have a method called sort. So I'll do sort, and you can see the sort method. There are basically two sort methods, but I'll be talking about it.
What's going on, everyone? Today we'll be doing a Java comparator tutorial. So we'll be going over what, why, how, and then a little demo about it. So by the end of the tutorial, you should be able to understand. Okay, so what is a Java comparator? It's basically used to sort custom objects in Java. So let's say you have a list of objects and you want to sort them in a unique way. You'll implement the int compare method on the comparator interface, and I'll get into what that means. So it's basically sorting objects. Okay, so why would we want to do this? I touched on this a little bit. So sometimes we need to sort objects in like a list or a tree map or other data structures in a custom way. So it's not just, integers can be sorted easily with like list.sort method, but let's say we have a list of objects. How do we sort that in a custom way? So that's what comparator can give us. So here's some examples. So example is, let's say we have a person object. I have an age, other people have ages. So how do we sort people by age? So that's one thing that comparator can help us with. And then another example would be sorting objects by time. Let's say there are maybe log objects or, order objects, and we want to display them sorted by time. So that might be something that comparator can also help us with. All right, so let's look at the how. So how does it work? So we basically need to implement the int compare method on the comparator interface. So comparator is an interface in Java, and it has a bunch of methods that we need to implement. So when we implement those, then Java will know how to sort these objects in a custom fashion. So you see here the return criteria from the int compare, because you're probably wondering why it's returning an int. So let's say we're given two ages, my age and someone else's age in a person object, right? So there's an age field in there. So we'll return 0, this first criteria here, if both of the objects are equal. So let's say my age and someone else's age, they're being compared and they're equal. So then we'll return value 0. So the second line there, if value is less than 0, then that means the first object, O1, is less than O2. So then that means O1 is smaller than O2. And then the third one.
Bom, pessoal, vou terminar aqui a live, porque amanhã eu vou começar a trampar de manhã. Mudei de turno, então 6 horas eu vou ter que estar em pé. E é isso. Antes de eu fazer lá no bagulho, eu vou ver uns vídeos de comparable. E é isso.